So that's what we call dihydroxyacetone phosphate. But this is a transition state. Okay, we go down. So we go down later on. Glyceraldehyde 3-phosphates become this guy. This is pretty much the thing you have to remember a little bit. This is hard to explain. Honestly. I teach so many years, this guy is hard. What is this? 1,3-biphosphoryl. And here is tricky. You need to add a phosphate from somewhere. That's a free available phosphate. And they're not coming from ATP. Lots of people will be confusing. And you lose hydrogen. So what happened here is NAD plus reduced to NADH2. This needs an enzyme called hydrogenase. This is the only place in the glycolysis cycle I think is tricky because nothing you can explain. And this one, lots of the textbook doesn't even mention where they come from. It's a free available oxygen. Okay, 1,3-biphosphoryl. Then you go down. This is not difficult. COOH, CHOH, CH2O phosphate, 3-phosphoglycerate. Here what happened? This phosphorate is gone. And we said the second stage is a payoff stage. You're going to generate ATP. So what happened is ADP, add phosphate, becomes ATP. This is a key thing right here. Okay, what's the enzyme? Phosphoglycerate kinase. Is that right? You need the enzyme is kinase. Now 3-phosphoglycerate. Then you go here to the top. That's a little bit easy. COH, C go, OP, then go CH2OH. What this called? That's called 2-phosphoglycerate. This needs an enzyme called mutase. 2-phosphoglycerate. Go down. Become COH, CO phosphate, CH2 double bonds, lose water. What's the enzyme for this one? Enolase. Enolization process is usually lose water. So what is this one called? 2-phosphoglycerate. This is phosphoenolpyruvate. And I tell you, this is extremely important during the glycolysis because this guy, at the end of the day, will be using on the top here for group translocation. That's phosphoenolpyruvate. Okay, what is the last step? Last step is easy. Pyruvate. Okay, so enzyme is pyruvate kinase. Where is this guy goes? ADP. Add phosphate becomes ATP. And this is pyruvate. Is that right? Yeah, all of them right. So where are the ATP comes? And how many ATP? 2 ATPs. But don't forget, this is a branch. 2 ATPs in one line, 2 ATPs in another line. So U multiplied by 2 is 4 ATPs. Okay? That's the story. So, not difficult. The only tricky thing here is really this guy. This is hard. When I was students, when I first do, because why this is a phosphate? The glycerol, they had a 3-phosphate become 1,3-biphosphogycerol. You think that the phosphates there, where they come from? Come from ATP. It's very easy to confuse it, but it's not. It's from free available. Now we can go back to study. 1,3-biphosphogycerate is right here. Phosphoenolpyruvate is here. Why they can generate ATP? Going through substrate level phosphorylation, because their phosphotransfer power expressed as absolute value of delta G prime is larger than ATP itself. Do you remember, if you go to see, this is pretty much like 46. This is like 61.9, if you remember. And what is this guy? What is this? What is that guy? This is the 31.5. Because their phosphotransfer power here, the chemical, is larger than ATP itself, that's why they can do substrate level phosphorylation. Now you're going to ask me, why glucose 6-phosphate you cannot do? This is small. This phosphotransfer power is only 13. So if you forgot, let's go back to see. If you forgot, we could go back to see slides number 1. That's why these materials are very interesting. If you really like it, it's pretty fun. And then you go here. See? Look at the slides there. Phosphoenolpyruvate 69.1 or 61.9. 1,3-biphosphogycerate 49.3. ATP hydrolyzed become ADP 31. Glucose 6-phosphate is only 13. That's why they cannot transfer phosphate. Okay? So, this is what we have today. Fermentation, glycolysis, we finished the talk. And on next week, Tuesday, we are going to go citric acid cycle. Then we have an overview picture of how the ATP going to generate. Okay, last thing. What I'm going through this is basically teach you about chemistry. This is not a biochemistry class. So if you already did very good, you are happy with your grade, you don't have to remember all these chemicals and the chemical structures. And what you need to know is how many ATP will generate and where the ATP will generate. And even briefly. Okay, you don't have to write all these. What I give these details is for people who haven't learned biochemistry and also give you an opportunity to make up some of the points if you didn't do very well in the exam 1 and the exam 2. So we have more to explain to you on next Tuesday. I will say, if you're happy about your exam, what you should do in this class. Okay? So that's all I have.
I didn't get that.